everyone, we're going to find the exact value of this expression. We have inverse functions here, and we're going to write this as alpha minus beta. So we have sine of alpha minus beta is right here. So we need a sine of alpha, a sine of beta. We also need cosine of alpha and cosine of beta. Now if this is your alpha, then we have sine. We're going to let alpha equal that. So sine of alpha equals negative 4/5. That means we're in quadrant 2. Remember the restrictions on your inverse trig functions. Sine is restricted to quadrants 4 and 1. So we're in quadrant 4. That means your cosine of alpha is going to be 3/5. And what I'm looking at is your Pythagorean triples. So basically, we don't need to do the Pythagorean theorem if we know our triples. So that means sine of alpha is negative 4/5, and cosine of alpha is 3/5. Now let's do the beta part. We have tan of beta equals 3/4. It's positive. That means we're in quadrant 1. That means my sine of beta, remember this is y divided by x. So that's going to be, sine is going to be 3 divided by 5. Because sine is your y value. And that's going to be y divided by r. Therefore, cosine of beta is going to be 4/5. Because that's your x over r. Sorry about this. X over r. So basically, let's write that in. We have sine of beta is 3/5, and cosine of beta is 4/5. Now we're just going to substitute in our values. Let's write out our formula. We have sine of alpha, cosine of beta, minus cosine of alpha, sine of beta. We can fill everything in. Sine of alpha is negative 4/5. Cosine of beta is 4/5. Minus cosine of alpha is 3/5. And sine of beta is 3/5 as well. So this gives you negative 16/25 minus 9/25, which equals negative 25 divided by 25, which equals negative 1. And that's your final answer. So basically when you do these, especially when they have these Pythagorean triples, if you know your Pythagorean triples, it makes everything a lot easier. And just remember your restrictions on your inverses, because that will give you a sign issue. Thank you. Have a nice day. Bye-bye.